Hello friends, today we shall solve examples on curl and divergence. So in the previous class we have discussed the definitions of curl and divergence. So the first example, if f bar is equal to del of x y cube z square, find divergence of f bar and curl of f bar at the point 1, -1, 1. For our convenience, let us choose phi, some function, as x y cube z square. So I have written here, I think it is repeated. Therefore, f bar will be what? Del phi. So that's equal to, you all remember a definition of the del, I into dou y dou x. When operated on phi, it will be dou phi upon dou x plus j into dou phi upon dou y plus k into dou phi upon dou z. That's equal to, it is the calculation of the partial derivatives here. Function is here. So with respect to x means you get y cube z square. With respect to y means 3x y square z square. With respect to z, this remains as it is. So 2 is taken here, 2xy cube z. This, for our convenience, we shall denote them as f1, f2, f3. So now your f bar will become f1i plus f2j plus f3k. Therefore, first we shall calculate divergence of f bar. Definition of divergence, you all remember, friends, del dot f bar. So, dou f1 upon dou x, dou f2 upon dou y, dou f3 upon dou z. In the definition of divergence of f, we have discussed this. We have obtained this formula. Now, f1 with respect to x. Just look at the components of f here. So when you differentiate with respect to x, you get 0. Then f2 when differentiated partially with respect to y, you get 6xyz square plus f3 with respect to z will give you 2xy cube. Taking 2xy common, what remains is 3z square plus y square. Therefore, divergence of f bar at a given point 1, -1, 1 is equal to, it is 2 into x is 1, y is 1. So -2 into bracket, it is 3 plus 1. So it is -8. So next part, curl of f bar. Del cross f. Friends, you all remember definition of curl f bar is the determinant whose first rows will be always I, j, k. Then components of del are dou by dou x, dou by dou y, dou by dou z. And that of f bar are f1, f2, f3. So first expand the determinant. I into suppress this row and this column, you get dou f3 upon dou y minus dou f2 upon dou z minus j into suppress this row and this column. What you get? Dou f3 upon dou x minus dou f1 upon dou z plus k into suppress this row and this column, dou f2 upon dou x minus dou f1 upon dou y. Okay, f1, f2, f3 already you have. So f3 with respect to y will give us 6xy square z and f2 with respect to z will give us 6xy square z minus j into f3 with respect to x 2y cube z minus f1 with respect to z will give you minus 2y cube z. Then here k, f2 with respect to x is 3xy square z square, and f1 with respect to y will be minus 3y square z square, and each term they are getting cancelled here. Thus curl f is equal to 0. So curl f is 0 means what here? F bar is rotational. Next example. If f bar is equal to x plus y plus 1 into I plus j minus x plus y into k, show that f bar dot curl f bar is equal to 0. It is only one dot. By mistake it has come from previous page. So let us denote f bar as f1i plus f2j plus f3k, where f1 will be what? X plus y plus 1. Then f2 it is 1. Then f3 minus x minus y. Curl f we shall calculate first. I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. Expand same expression like previous sum. Then we have to calculate this. So this is equal to I cap into minus 1 minus 0 minus j into minus 1 minus 0 plus k into 0 minus 1, and curl f will come to minus I plus j minus k. Therefore f bar dot curl f bar we are asked to find. So consider that f bar is the given vector function x plus y plus 1 into I plus j minus of x plus y into k dot curl f we have calculated, it is minus a plus j minus k. Friends, you all remember dot product. Only corresponding coefficients of y, j, k are to be multiplied. So here it is x plus y plus 1, here it is minus 1. So minus of x plus y plus 1, 1 into 1 plus 1, then minus of x plus y into minus 1 will give you x plus y. Cancel plus x plus y with minus x minus y, minus 1 plus 1. So the value of f bar dot curl f bar is 0. Simple problem. Next example, if v bar is equal to w bar cross r bar. V bar is some vector expressed as what? Cross product of two other vectors, w bar and r bar. Question is, prove that curl of v bar is equal to 2 times w bar. Okay. Now v bar is given to be what? W bar cross r bar. We shall calculate that. W bar cross r bar, I, j, k components we can take them as w1, w2, w3. R bar you take it as r1, r2, r3. Expand it. I into w2 r3 minus w3 r2 minus j into w1 r3 minus w3 r1 plus k into subtracting this row and this column w1 r2 minus w2 r1. Now let us take r bar is equal to xi plus yj plus zk. So that's equal to I into w2z minus w3y minus, I have substituted for r1, r2, r3. Okay. So you get v1i plus v2j plus v3k. What is our v1 here? w2 r3 minus w3 r2. That is w2z minus w3y. So that you can understand more clearly. Then v2 is what? Minus of w1 r3 minus w3 r1. So w3x minus w1z. Similarly v3 we get w1y minus w2x. Now we shall calculate curl of V bar. I, J, K, dou by dou X, dou by dou Y, dou by dou Z, because we are asked to consider this. Expand this I into dou V3 upon dou X minus dou V2 upon dou Z minus J into dou V3 upon dou X minus dou V1 upon dou Z plus K into dou V2 upon dou X minus dou V1 upon dou Y. So I cap into, when you differentiate V3 partially with respect to Y, we get W1, and here you get minus of W1. So it becomes plus W1. Minus J into minus W2 and plus K into W3 minus of minus W3. So this will be 2W1I plus 2W2J plus 2W3J. Take 2 common, and what remains is, it is W bar. Thus, we proved that curl V bar is equal to 2W bar. It is an important sum. Next example, show that F bar is equal to xi plus yj upon x square plus y square is both solenoidal and irrotational. So consider F bar into 2, express it in terms of 2 terms. Splitting the term, we get x upon x square plus y square into I plus y upon x square plus y square into j. This we shall denote it as F1 and F2, where F1 is x upon x square plus y square and F2 y upon x square plus y square. So first we shall consider divergence of F bar. We want to prove that it is solenoidal, and friends, you all remember, to prove that it is solenoidal, I have to prove divergence of F bar is equal to 0. But you should show the actual calculation. So this is equal to del dot F bar. Del is by definition this, dot F bar is F1I plus F2J. So dou F1 upon dou X dot product, dou F2 upon dou Y. Third component is not here, so it becomes 0. F1 with respect to X, just see carefully here, X is there in numerator as well as denominator. So U by V formula is to be used here. So x square plus y square the whole square, keep denominator as it is, x square plus y square, into derivative of numerator, that is 1, minus numerator kept as it is, derivative of denominator only 2x you get, plus similarly F2 with respect to y. Now y is there in numerator and denominator. Here also I have to apply u by v. X square plus y square the whole square, same x square plus y square kept in numerator, derivative of numerator 1 minus numerator, keep it as it is, into derivative of denominator 2y. Denominators are same here, x square plus y square the whole square. Numerator, what do you get? Just see, x square plus y square minus 2x square means y square minus x square, and here x square minus y square. So y square minus y square, x square minus x square. You get divergence of F bar is equal to 0. Therefore, F bar is solenoidal. First part. Now second part, curl F bar is del cross F by definition. So this is equal to, del is, you all know here, cross F bar is F1I plus F2J. Substitute in the determinant I, J, K, dou by dou X, dou by dou Y, dou by dou Z. Then F1, F2, no third component, you should take it as 0. Remember this. So I into expanding this, it is 0 minus dou F2 upon dou Z minus J into 0 minus dou F1 upon dou Z plus K into dou F2 upon dou X minus dou F1 upon dou Y. And F1 and F2 already they are there, so we have to substitute the respective values now. So this is equal to, first two terms will be 0 there. So plus k into, you have to apply u by v formula there, x square plus y square into all that here also. Then simplifying that, it comes, this term vanishes. So minus 2xy upon x square plus y square, the whole square it should be. By mistake I have not written there. Please make the correction. Plus 2xy upon x square plus y square, the whole square. They also get cancelled. You get 0. Therefore, F bar is irrotational. The next problem is, show that F bar is equal to 2xy square plus yz into I plus 2x square y plus xz plus 2yz square into j plus 2y square z plus xy into k is a conservative force field. Find its scalar potential. So I just explained here, to prove that it is a conservative force field, it is just another name. So just you have to prove that it is irrotational or curl F bar is 0. And the second part of this problem is, find its scalar potential, means find phi such that F bar is equal to del phi. So first part we shall prove. Let F bar be equal to F1i plus F2j plus F3k, where F1 is equal to 2xy square plus yz, F2 2x square y plus xz, then plus 2yz square, and F3 2y square z plus xy. Now consider curl F, that is del cross F, I, j, k, dou by dou x, dou by dou y, dou by dou z, F1, F2, F3. Expansion we have done in the previous sums, same method. So I into F3 with respect to y. Your F3 is here. With respect to y means it will be 4yz, then plus x, minus F2 with respect to z. F2 is here. With respect to z means there is no z in this term. This becomes 0. This will be x, and again this will be 0. So you get only minus x. F2 with respect to z. F1, F2, F3 with respect to z. One second. So first part, I into dou F3 upon dou y is 4yz plus x, and dou F2 with respect to z, it will be minus x minus 4yz. Like that, j into y minus y, k into 4xy plus z minus 4xy minus z. So it comes 0 means curl F is what? 0. So F bar is conservative or irrotational. Next we have to find phi such that del phi equal to F bar. So del phi is what? Dou phi upon dou x into I plus dou phi upon dou y into j, dou phi upon dou z into k. This is equal to F bar, all given function you write down. So you get 3 equations, partial differential equations. Dou phi upon dou x is equal to 2xy square plus yz. Then dou phi upon dou y is 2x square y plus xz plus 2yz square. Dou phi upon dou z is 2y square z plus xy. So consider first one, dou phi upon dou x is equal to 2xy square plus yz. So to find phi here, we have to integrate it with respect to x, keeping y and z constants. Therefore, integrating with respect to x, we get phi is equal to 2xy square plus yz into dx. I have to add constant of integration. I will add some function of yz, because y and z we have treated as constants. So this will give you phi is equal to 2 this y square is constant, integral of 2x is x square. So it becomes y square into 2x square upon 2 plus yz x plus f1 yz. Therefore, phi is equal to x square y square plus xyz plus f1 yz. Call it as equation 1. Similarly, dou phi upon dou y is equal to 2x square y plus xz plus 2yz square. Integrate on both sides with respect to y, keeping x and z constant. So phi is equal to integral all this with respect to y plus constant of integration is some function, that is f2, containing variables x and z. Therefore, phi is equal to, we get x square y square plus xyz plus y square z square. Call it as equation 2. Next, third one, dou phi upon dou z is equal to 2y square z plus xy. Therefore, phi is equal to integral 2y square z plus xy into dz plus f3 xy, because you are integrating with respect to z, keeping xy constant. So phi is equal to, we get y square z square plus xyz plus f3 xy. Now you have to choose f1, f2, f3 such that depending on which term is missing. So in f1 yz, y square z square is not there. So choose that. f2 zx, z square x square, and f3 xy, you can see x square y square is missing. And from 1 to 3, if you use this in any of these equations, you get a unique equation. Phi is equal to x square y square plus y square z square plus xyz is the required scalar potential. Friends, these are some of the examples on divergence and curl. So in our next lecture, we shall solve the next part of the problems. Thank you.
That's all, friends, today in this video lecture. If you have understood the explanation, please like and share this video with your friends. Please subscribe to this YouTube channel if you have not yet subscribed. Click the bell icon for the latest notification of the videos on this YouTube channel. Show us your support by following us on Twitter, Instagram, and like our Facebook page, Mechanical Engineering Tutorials. The links are in the description below. So friends, thank you very much.